We're good. Hi, I'm Ed Burns,
I'm Joey Schluchter.
and we're here to talk to you about developing business applications with Azure for Red Hat OpenShift. Is everyone having a good conference so far? You are groundbreakers here. This is the J4K Prequel, and you'll notice that there's just two of us up here, and we're both males. Teresa is right now in a meeting that is determining the future of J4K. So please make sure you make your feelings known about what you think about it, because we'd like to take this into a larger event. So you guys are, just by being here, the groundbreakers of the J4K conference franchise. So before we go on, just take an opportunity to introduce myself. I see a lot of people that I know from the old Java days. This is actually my first presentation as a Microsoft employee. I joined Microsoft in June of this year after being at Oracle for a very long time and Sun before that. And while I was there, I worked on Java EE and had a chance to be on the inside of the specifications. I was the spec lead for JSF and Servlet, two parts of the Java EE specification. And I got to experience firsthand what it's like to be disrupted by the cloud. So I also have a perspective on portability. So Java EE, as Adam Bean was talking about, gives you the ability to isolate yourself from a particular app server runtime environment. Kubernetes, which we'll be talking about today, gives you the ability to isolate yourself from any particular one cloud runtime environment. Now, because we're here with Microsoft, we're going to be talking to you about how great Azure is and how great Azure is for Kubernetes. But Kubernetes itself can be seen as like a WebSphere for millennials, pretty much. It's a runtime environment that gives you portability, but really is just an app server that goes to the entire IT enterprise, whereas previous app servers were just like single node, single programming language thing. Kubernetes is a much broader scope.
I'm Joey Schluchter. Been at Microsoft for 4 years, roughly. I'm on the Intelligent Cloud Black Belt team, specifically for open source, and that, as you know, Kubernetes being the new hotness and kind of the it thing, that lends itself a lot to that, which is AKS, ARO, which is our Azure Red Hat OpenShift offering, and anything along those lines. My background isn't as diverse or as lengthy as Ed's, but prior to Microsoft, I was at several startups, social media, et cetera, and that just kind of parlayed itself into an employee at Microsoft. So feel free, and all of our contact info is up here. You know, you can follow us on Twitter, email us, hit us on LinkedIn, but we probably think you're a recruiter. So, all right. So part of the demo is, obviously, you've got the Star Wars VR experience tonight. You can go out there right now. It's aka.ms/J4K.
Right. So go to this URL right now on your laptop or phone, and you will get to see the demo that Joey put together. He's going to talk to you later. But the reason we want to have you look at this now is because it's interactive, and the more data we put into it in the room here, the more fun it'll be.
Yeah, absolutely. Go out there. Vote for whoever you may think, and then, comments about whether there should be Luke Skywalker or Yoda or anything like that. So,
Mike had a question. Hey, does anybody have the Wi-Fi? It's on the back of your badge. Yep. The question was, where's the Wi-Fi info? The answer is on the back of your badge. And one of the things, see, I got the beginner's mind at Microsoft, so everyone at Microsoft just assumes the whole world knows what this thing is. I did not know. It's an URL shortener that's Microsoft specific.
Yep.
So it's like Bitly, but for Microsoft stuff, or anything. Like, we as employees can put stuff in it and make URLs. All right, so this is our plan for your time investment. I hope you had a nice lunch, and I'm glad you're here leaving lunch. You probably could still be eating right now, so I'm glad you're here with us. We're going to be talking, first start out with a word from Brendon Burns. Brendon Burns is not my brother. Well, actually, he is my brother. My brother's name is Brendon Burns, but this Brendon Burns is not my brother. He works at Microsoft. He's one of the founders of Kubernetes, and I talked to him as part of my Rockstar Programmers project that I have. It's kind of a side hustle. Where I interview programmers and talk to them about their jobs and what they do and how they stay current and all that kind of stuff. Wrote a book about it, have some talks about it. And I wanted to ask him about Kubernetes for people that are coming to it from the app server world. So how many people here are familiar with the app server way of living, the lifestyle? right? Okay. And how about have the same level of depth of experience with Kubernetes? Anyone here? Very good. So I find coming from one space to the other, it's helpful to kind of conceptualize things in the app server way, and this is natural to me because I worked on WebLogic and worked on Glassfish, and so I know what it's like to live inside an app server. But in this new world, a lot of things are different, but a lot of things are the same if you take a step back and look at it a different way. So let's see what Brendon Burns has to say about that. So I have a little clip. I interviewed him, and we're going to play that clip now.
In many cases, the things that you learn there still apply, right? You're still writing multi-threaded programs. I think that the biggest challenge is wrapping your head around how do you debug and deploy when there's lots of replicas of the same thing. You're going to have to start learning some tools that do things like aggregate log, right? It's no longer okay to just log into a machine and dump its logs. Now you need to have a tool that aggregates all of the logs across a bunch of different servers into one. And then because of the volume, do querying. So your problem has become one of more of a data scientist than just a person who's a developer reading log lines.
So the takeaway there is you're going to have to learn some new tools. Paul Parkinson showed the Kiala. Was that what it's called? Yeah. And then we also have Kibana. I'm not sure why this both start with K and both do the same thing, but Kibana is another way of visualizing log servers. So, don't be afraid. You're going to have to learn new tools. That's okay.
I just want to make sure we get to that one.
Okay, so we'll have a few riffs on cloud native architecture. What do we mean by cloud, and how is that related to Azure? So this is a handy demo that's been, or not demo, this is basically a PDF from the National Institutes of Standards that define what a cloud is. And one of the things that I find challenging, coming from one technology stack to another, is variance in terms. So if we as an industry could do a better job of using the same terms for the same things in all different contexts, that would be useful for all of us. So if you haven't yet looked at this, this is like, this defines PaaS, SaaS, IaaS, all of those things which we talk about, but it gives a rigorous definition to that. So what for us, what NIST says is a cloud has to be on-demand, self-service, requires broad network access, resource pooling, rapid elasticity, spinning things up and down, and everything being totally auditable. Of course, Azure does all of that quite well, and just take a look at that link, and you'll see that. That's okay.
All right. There you go.
Okay, so there's a ton of stuff on Azure. Our CEO Satya Nadella likes to position Azure as the world's computer, and a lot of times you could look at what CEOs are saying and like, oh, that's just CEO speak. But this really is accurate. I mean, we have data centers all over the world, and we have a huge array of services, and these cloud native services are able to have Java API bindings. So all of the things up on that top row there, you can talk to directly from Java. From lift and shift to on-premise VMs. We have managed services for platform storage, microservices, containers, and a lot more. And, we understand that IT is a very sticky thing. So we want to meet developers where they are. So if you're familiar with using, Maven or Gradle, we have build stacks that support that for both. What else can we say on this one?
Well, I do have a kind of a door prize.
Oh, good.
So who can just give me a good guess on what the percentage of workloads of Linux are on Azure right now? You got to be, but then we're going to go Bob Barker. You can't go over. You can go under. Go ahead, right there. 40%. Nope. 60. A little high. Oh, never mind then. Somebody has to answer now. So. It's like 57. This says 50%, but it's like 57%. So if somebody wants to catch this, if you think you can catch her, I'm going to tag somebody in the head.
Mike's a good guy. He's got it.
Oh, there we go.
Good thing it's not ceramic.
Yes. Well,
so basically, people can be surprised that Microsoft, Windows, they're the Windows VM people. Mm-hmm. No, actually, 50% of what's running on Azure, which is a lot, is all 100% Linux based.
Yeah, and I would say, as we talk about Arrow and AKS and Kubernetes in general, the #1 growing service in the history of Azure right now is AKS.
The Azure Kubernetes service.
Yeah, it is by far the fastest growing service. So as we talk more about cloud native and everything like that, you're going to see that that's just a rapidly growing segment. So I guess now we can step into a little bit of demo, and let's before we do that, I'll come back to the slideshow. I'm going to pull up a little. Let's just see where we're at here.
Did anyone get in and do some voting?
Nobody voted yet?
All right, great.
Okay, good. So here we go. Let's just go to the leaderboard here. Okay, so we've got Leia, Hooray, Finn. Oh, it's good. We downvoted Kylo. Because there's another variant of this where it's DC superheroes, Batman, Superman, Wonder Woman, and everything like that. And my Twitter handle is Son of Jor, also Superman always. Well, my teammates always vote up Batman. And it turned into a huge thing. And so I'm surprised that nobody did that, okay? So the front end here, really the app is irrelevant, okay? And we're talking about business apps and everything. Ultimately, you're just going to break it down into services. In this case, there's a front end and there's an API, and then it's hitting, in this case, I'm leveraging Cosmos DB as the back end, all right? And I can kind of bring you up the OpenShift console. Let me just bring this up for you, which you can come into and take a look at. But basically, not unlike, how many of you have played with OpenShift at all? No, we got 3 people. Well, guess what? You're going to learn something today. I mean, the one thing this does, in terms of, as opposed to just stock or vanilla Kubernetes, it builds an overlay that you can deploy things to. So if I were to come in here and I can just go to Service Catalog, you can see all the different available options on there. I find it ironic that .NET Core is first, on an OpenShift thing. But
That's lexically first because of the dot.
Exactly. So, and you can see, there's a ton of different languages, and this is just some of them. You can search for other ones, install other different plugins, anything like that. But for this scenario, I was just deploying the app out there, had it locally. How do you get it out there or anything like that? So basically, what you can do is point it to, there's a couple different scenarios in which you can do it. You can have it so that it uses Jenkins, or you can point it at a GitHub repo, and then it'll build the project for you. It'll detect, the language that you've got, and kind of use a build pack. If you're familiar with how Pivotal does it, in this case, it detects all of that for you, all right? And then builds it from that scenario. So let me go and grab my terminal here. And so just real time, what we'll do, so that you can see this right quick. So we've got it out there. We can go and take a look at it. I'm going to pull up VS Code, and I'm going to edit that home page, and hopefully we can see something right out there. And so we're going to say J4. Let me move this over to the other screen so you guys can actually see what I'm doing and not like fudging it for you. And I will zoom in there for you. Okay, and so currently on that site there, if we take a look at this, right down at the bottom it just says J4KO. All right, I'm just going to show you how simply it is to make changes, everything like that. And you could apply this to your CI/CD process in many different ways. You obviously wouldn't want people deploying right to production, but you could have different branches, and how OpenShift and Kubernetes space it out. You could have different namespaces, or basically different environments for those things. But in this case, I'm going to just go ahead and modify this real quick and just say rocks. All right, we'll go ahead and save that. I'm going to go back to my command line here, and I'm going to just say, let me zoom in there so you guys, hopefully everyone here has used Git.
Right, so he's doing a Git commit and push, I guess, right?
Yeah.
And this is going to push it over to GitHub, right?
Correct, yeah, it's going to push to GitHub.
And so the CI/CD pipeline is set up to watch for commits.
Yes.
And it's going to kick that off. So, any old thing like you normally expect CI/CD to do.
There we go. Oh, pardon me. This is where, when you set up the demos, you have all these different, origins, okay?
Yeah.
And so, hey, it's out there, everything like that. And what we can do, go over here, we can go to the OpenShift console, and as we bring up the application, we can see this right here, and we're going to say the web, and this will take a few seconds, okay? It's actually, this was 2 hours ago. This will take a second. That hook will come in, it'll go and pull those changes. It'll look what the differences are, not unlike any other CI/CD system. This could, and it's going to, basically it's going to build the Docker image for you using source to image and then deploy it all out like that. So as it's doing that, I'll go over there and show you. You come in here and you can set up your environment variables like what your app would have. I saw someone using Kafka earlier. There's a lot of scenarios like that where you're going to have to point to, you know, the different producer-consumer scenarios or anything like that that are Zookeeper, etc. So as we come back here and take a peek here, we can see it. Where is it going right quick? Maybe we can refresh it from that. I think it might have popped in here any second now. Oh, pardon me. We'll refresh this. It's taking longer than what you would expect.
That's okay.
So, because you can see, oh, there it comes. Here we go, I think.
So this CI/CD that's happening here, is this all part of the Red Hat OpenShift environment?
Yeah, this is baked, by the way, this is baked into the OpenShift platform. This
right.
is, you can come in here and set up these different webhooks that are built in. Basically, you're going to get those keys from there, your secret, the URL that's out there, and then you're going to, you know, obviously tie it into GitHub, and then once GitHub sends that push notification out, then, you know, it's going to be able to see those and act on those changes. The same thing would happen as if you were using Jenkins or Azure DevOps or Bamboo or whatever CI/CD system that you may be using from that perspective. Let me just make sure that this is, I'm going to refresh this just so it's thinking correctly.
So what we can point out is OpenShift is a proper superset of Kubernetes itself. So everything you can do with kubectl and you know, custom resource definitions and you know, all the things you know expect from Kubernetes, you can do with OpenShift. The value add, of course, is all of the stuff that Joey's showing here with the CI/CD integration, the source to Docker, that kind of stuff that's not in plain vanilla Kubernetes.
Yeah, and so what we see here, it actually went, and this is some of the, you know, the demo gods just messing with me, but basically what it's doing, it's building that, it's got a standard kind of build image that it goes through, and then it takes all that content, builds it out, and then pushes it to an in-cluster Docker registry, okay? So that's out there. It should be currently running right now if we were to take a look at this.
So the in-cluster Docker registry is backed by the Azure Container Registry, is that right?
And in this case, it's not.
Oh,
this one is within.
It's part of OpenShift.
It's part of OpenShift.
Okay.
You can have it back. If you want to use our Azure Container Registry, you can have it point directly to that if you want to. And what that'll do, there's a limited amount of storage you've got here. All right, it's whatever you've assigned to the nodes or anything like that. If you wanted to, you know, just leverage our ACR and then just have unlimited storage, then there's a little bit of configuration, but it's just basically you can implicitly trust it, or you can add those secrets in there from that perspective.
And the benefit of doing that is if you put it in Azure Container Registry, then you're able to leverage it outside of just what's happening in OpenShift. So you might have other kind of things that are doing telemetry or Internet of Things, because I mentioned, you know, that huge array of technologies that you can touch from Azure. With having Azure Container Registry be the backing store for the in-cluster Docker registry, you're able to do kind of a sharing of images that way.
Yeah, and that's the one benefit there is, as you'll see, by the way, it updated, but right. As you'll see, when you're dealing with the images become large, and moving them around becomes, you know, kind of hefty. It does some pre-caching. What this does, it'll do some pre-caching of the images, just look for the layering and everything like that. And ACR has some of those enhancements, but normally what customers do is they'll use ACR as an intermediary to their cluster or something like that. So,
so remember when I said about the cloud definition is totally auditable. That means billing. That means you pay actual money for everything, every cycle of CPU, every kilobyte of network traffic. So if you're shuffling multi-gigabyte Docker images around, you're paying for all that network traffic. That's something you want to minimize too, if you can.
Yeah, exactly. And so just from a scaling perspective, you obviously wouldn't want to do this manually, but just from the ease of use thing, say that, look, I'm getting a lot of traffic and I know that it's going to, you could warm it up, you can bump it up so that there's 2 pods, and so you're scaling within the cluster. There's some other options that are platform-based where you're going to have to add VMs along those lines, but it's just as simple as, a click of a button or a command line switch, or it can act on metrics if you wanted it to from that perspective. Beyond that, I think we're good with the any questions on the demo or OpenShift in general, that type of thing? No questions, everybody's good? Okay, all right, back to the presentation real quick. Let's go back here, and we'll go. Okay, and so if you were to run your own Red Hat, look, you get some, and this is rolling your own on IaaS, you get some platform support from us. Okay, so look, the VMs are down, or there's something going on. You can open a support ticket, and it's kind of hard to. You're gonna have to update all the nodes, handle all of that, and then whereas with our managed, Microsoft and Red Hat handle that. Okay, so I deal with a ton of customers, and ultimately they want someone to strangle. I know it sounds weird, but ultimately they want someone on the other that's actually responsible. In the roll your own, you're the person responsible. In this scenario, the cluster creation, it's quite simple. There's you can follow through the docs on that. The cluster management, we handle all of that. Monitoring and logging, out of the box you'll get a lot of that from us, but you can extend your own if you want to and use your own. The network configuration, like I said, it's out of the box. It'll tie into a VNet, or you can put it on another VNet if you want to, and it'll eventually, right now it's not, but eventually it'll tie back on-prem if you're using ExpressRoute or a VPN connection. But the big thing here is the software and security updates. We'll manage all the updates to those VMs, both the master and the the agent nodes that are there. And for most customers, I can tell you a story about pre-Kubernetes. There was a huge retail customer that was running Mesos, and it had been months that they had updated those agent nodes, and they thought, oh, we thought you, as in Azure, did that. And it's not necessarily a fine print thing. We tell you up front, hey, you have to manage that. In this scenario, this takes all of that away from you. And then the other thing is platform support. You're going to be able to get someone on the phone right away, either Red Hat or Microsoft. In this case, it's going to be Red Hat, Microsoft engineers that are 24/7. And in most circumstances, they're going to know of issues ahead of when you know about them. But if there is an issue outside of those scenarios, you can certainly talk to them. So this is right now, as you can see there, the VPN connectivity back to the customer, that is coming right now. But these are all the different kind of scenarios that play into that. The premium support that I talked about, this is kind of, we did all of that scenario. So, by the way, OpenShift in general, you can run it anywhere. And this is the one benefit of it. Hey, I've got an OpenShift cluster on-prem. I want to connect it up to the one that's in the cloud. That's the scenario. It's going to be hybrid environments that customers use. It's big in banking. A lot of retailers use it. It's hardened images. I mean, there's a lot to it that a lot of customers use. And there's kind of a big platform around that from that perspective.
So when you log into the OpenShift Red Hat portal, you'll get presented with this nice friendly dialog here. These are actually buttons you can click on. And we're going to click on the Azure button because we're going to be talking about that. And this just goes to show or graphically illustrate what Kubernetes enables in terms of cloud portability. However, there are a lot of value adds that you get when you go into the Azure Red Hat OpenShift.
How many of you use Azure? Okay. Well, look, you guys deserve stickers or something like that. I'll figure something out for you guys. But basically, any modern enterprise, I would say that I think we're in 90% of Fortune 500 companies. And it's mostly either due to the cloud or Azure AD. And so if you can see on that third line item there, it's the Azure AD integration that makes it so seamless. For something like this, then you can control who can deploy out there with Azure Active Directory. Hey, who's going to actually be able to do that? Who can modify things? Who can scale things, et cetera, et cetera. So let's skip through that. Yeah, we kind of did a lot of this.
Right, so this shows you the three different columns of how to get OpenShift. With the one we're talking about most on the left is ARO, Azure Red Hat OpenShift. The middle column is the OpenShift Cloud Platform, OCP. You can run that on any of the public clouds. And then on the right side, there's the Azure Red Hat OpenShift Dedicated, which is the one that you get when you go over to Amazon. So the fully managed, let me go back. I'm not quite done with that one. Okay. The left column is a fully managed solution. So Microsoft and Red Hat manage all of the infrastructure for you, apply the security best practices, keep the images updated. If there's a CVE vulnerability that's detected in any of the Docker images that you're depending on, that kind of stuff is taken care of for you. Where the OCP, that's much more of a do-it-yourself solution. And of course, do-it-yourself means also support it yourself, right? And then the OSD, managed by Red Hat on AWS, that's just platform support, and there's infrastructure provided by AWS. So this system here is really made for developer productivity, and I talked about the not having vendor lock-in. Well, that applies on the bottom layer to your infrastructure, but it also applies on the top layer of OpenShift, because OpenShift being a proper Kubernetes implementation, therefore everything is Dockerized and containerized. It's not just Java, it's not just Python, Go, whatever. It's anything that you can think of that can be containerized and run is able to run in that system. So because of my background, I'll just talk a little bit, and because this is J4K, a little bit about the Spring and Java EE aspect. Really that's enterprise Java at this point. And Jakarta EE, it says Java EE, but it could be Jakarta EE and microprofile as well. There is quite a bit of complexity when you're in a pure Java shop mapping to the way you have to go in cloud native. So Java has its own way, and app servers have their own way of dealing with all of these concerns here. And the way that's done in Kubernetes is different. So one of the challenges that enterprises face when migrating from an app server into a Kubernetes world is handling how scale up, scale down is based in terms of memory throughput and CPU. There's also the concept of health checks. App servers didn't usually have health checks because they weren't really microservices environments. So a health check is basically common in microservices worlds where the Kubernetes runtime itself can be configured to ask each individual microservice, are you still up? Do I need to bring up more of you? Do I need to shut you down because you're not responding to network traffic?
And I would say that that's the biggest, what I see when customers, they're moving to, they're saying, I'm going to do lift and shift. I'm going to just push, they forget about the health endpoint, all right? And that's, it's one basically REST call that you can add to all of your services so that Kubernetes can take a look at this. And, yep.
Well, I'll let you finish your sentence.
All right.
Okay, yeah.
Well, I'm curious, when you talk to customers, do you see them actually writing custom endpoints with business logic as a part of their health checks? Or do they just basically ping an endpoint and see if it's up or down?
So the question was, do customers, when they do the transition, write their own business logic or internals to actually respond to the logic? That's a very good question. And it also dovetails with another concern, which is in microservices environments, what do you mean is healthy? Because if you're an upstream service, you might be up and running, so Kubernetes calls you and says, you're healthy. Yes, I am healthy. However, I can't do anything because I can't talk to any of my downstream services. So you have to make that query be more responsive there. So go ahead.
The customization piece, I think that initially, no, because they just throw it up there and they're like, okay, it's running. But yes, to what Ed is saying, then it becomes, okay, it's running, but it's having errors, it can't connect, And that's where it goes hand in hand with, logging. Basically, if you write everything to standard out, then you're good to go on all your errors. But to have that health check so that it does some more customized things to match your needs. Let's put it that way. So.
Another thing that is quite different, most enterprise Java apps are highly stateful. So, and because we made it easy to do that, the technology that Paul developed with JTA and Java, we were like, let's make it as easy as possible for developers to look at the world as entirely consistent all the time. And that's a really great way to develop, but it's challenging to scale that up to cloud level things, and that's why we've had the rise of eventual consistency. So, oh my goodness, we only have 10 minutes left. Mm-hmm. That doesn't seem right.
It doesn't. Real quick, on that, what are you saying about stateful? I notice that more and more customers are trying that, but the more experienced customers that use Kubernetes in this OpenShift, Kubernetes type scenarios, they'll use a PaaS or manage their own IaaS to manage their state in some way, shape, or form. It just, right now, it's very tough to do state within Kubernetes. And all the goodness that's there from scaling and health, you would take away from that perspective. Now, and by the way, we have in-house projects on this for SQL and Oracle, ironically, that are saying, oh yeah, it'll work. I'm dubious, so I would say tread lightly when you're using state from that perspective.
Okay, so we'll just go through these next ones quickly here. We're trying to show kind of the cloud native application lifecycle. So first we'll look at build. The big picture of build is we have lots of different inputs that are able to interface through lots of different channels to get to Kubernetes or the IoT with our event hub here. And we also have Azure Functions, one of which languages that support it is Java, of course, as a first-class citizen. Logic apps, and then we have lots of different tools for developers to work with to interface with the cloud. And this is talking about some of the open source ecosystem that we're leveraging here. So at all stages of this build, integrate, deploy, manage, and scale, we're leveraging open source technologies from all of the different foundations that are out there, you can see. We have very good first-class tooling support. We have this basically bring your own. You can use Jenkins for CI/CD. You can also use Azure DevOps. And we have Visual Studio Code extensions. We have very good support. We've partnered with Eclipse and Red Hat to develop the Java extension pack. And Visual Studio Code for Java is fast growing and seen as a very good tool
How many of
environment.
you use VS Code for Java development? Okay. Yeah, I mean, I would say that it's rapidly becoming the IDE of choice no matter what the language is. And I think it'll just only grow. And as we build these partnerships, it's going to be really impressive from that perspective.
But it is important to recognize that the cloud is about meeting developers where they are, and many Java developers are still quite comfortable with using either straight up Eclipse or IntelliJ. So we have Azure extensions for both of those popular IDEs as well. So this slide kind of drills down on the things that are in Azure that are first-class support for Java and Kubernetes. So these slides are available for you to take a look at, and we do encourage you to do that because there's a lot of text, a lot of good information on these slides. So I won't go through all of them, but Microsoft is very serious about Java now, as evidenced by the fact that I am here at Microsoft, and a lot of other people that are coming from the Java world are excited about doing Java at Microsoft. Yes, question?
Yeah, it seems as though Helm is becoming a bigger part of use in Kubernetes, and especially for CI/CD.
Right.
How does this? Do you have any special thoughts?
We do have some content on Helm and Operators. Paul talked about the importance of the WebLogic operator for Kubernetes. We're going to be leveraging that exact thing for bringing Java technologies to the Azure Marketplace. But we're also have some offerings that deal specifically with Helm and Operators. And we can talk about that.
Yeah, what I'll say in that is the Helm is a piece of that, okay? The operator, kind of scenario will be much bigger than that. But Helm, the company that made Helm, Deus, we purchased, and now Gabe Monroy, the CEO of that company, is now the head of our container compute. So Helm is a huge part of that. Helm 3 is due to be released, you can go and download it, but due to be released and integrated with Kubernetes shortly. That's going to, if you're familiar with how Helm worked before, where you had a tiller and it kind of managed all that, your deployments within there, in the new version, it goes away.
Tillerless Helm.
Yes, exactly. So you're going to see an emergence of operators in the next 6 months, in my opinion. It'll be all about that. And the way that you deploy with Helm today, like if you were to just try to do Helm, yeah, that's not going to happen anymore. It's going to be, operator does it, and you basically, the operator handles it in some way, shape, or form. So.
Yeah, when I was looking at what Helm versus operators, it definitely seemed to me like operators were a much more complete solution. So Helm is just kind of a transitional step, although it'll still be there under the covers.
Yeah, you're going to modify. You're still going to modify the values and everything like that, your configuration, but it won't be the same way it was before. So.
Okay, this one talks quickly about the importance of SQL database support for Java on Azure. We have 9 of the top 10 databases listed on dbengines.com as well supported in Azure. Ironically, the one we don't support is Microsoft Access. So it's in that database engine list, but we actually don't currently support it.
That is comedy. Actually, when we were going through, I was dubious, and so I was like, I'm going to go
We
out
checked.
on Azure and check, and it wasn't there.
Wasn't
so.
there, right. And you may have heard that we announced a really deep partnership with Oracle on Azure for the Oracle DB, and that allows you to have the Oracle database running in the Oracle Cloud physically nearby the data center at Microsoft where your applications are hosted, and we're currently building up the infrastructure to have that, so you can have really high-end database performance provided by Oracle and really high-end cloud infrastructure and speed for all of the other parts of the concern provided by Microsoft.
You familiar with Jet? Got bought by Walmart.
Jet.com, yeah, it's an online retailer.
Anyway, you can go there and you can, I won't sell you on their product, but basically they were the largest Azure customer until Walmart bought them, and then now Walmart is. But basically, with Cosmos DB, and I think this number's a little low, but it's 100 trillion transactions per day. So that's every time somebody browses a website or anything like that. And it's single-digit latency, and that's between regions as well. So when they're replicating between regions, it's single-digit. I encourage you, I'd love to talk more about that, but we'll plow through these slides.
Yeah, I'll talk to this one. So
yeah.
I mentioned the importance of globally distributed data centers. So Cosmos DB is interesting from a number of perspectives. First is, at the top layer, you can talk to Cosmos DB using the API that you're familiar with. So it's truly a frictionless experience. Secondly, we have global distribution network all the way with some of these low latency guarantees that we can give you. And that's it's also no SQL. So it's what's it called? It's not relational. It's object based.
Yeah. Which real quick on that. By the way, the sub 10 millisecond replica, if you are in a paired region, that is 100% accurate right there. So on the dev with, let me just see right quick. So basically, anything that you may do with Azure Functions, you can have it be triggered. We've built a lot around being able to leverage Azure services based on other Azure services. So functions, say that you have something happen with a function, you can have it trigger a build, or it's leveraging GitHub, and then it can trigger a function, something along those lines. And the bindings, you can use table storage, SQL, event hubs, app notifications, anything like that, using, and then you can leverage app service to actually execute that in some way, shape, or form. Output bindings, you can have it, and it's not only just Azure services, we now have it to other services as well. And then, hey, monitoring that are built in there, you can use your own or our built-in ones, develop locally, and then push it out to CI/CD, either Jenkins or whatever else you may want to do.
So let's drill down on that with the particular use case of uploading a photo to storage and do some kind of processing on the image with functions. So without Azure Functions, you'd have to do all of these steps, that were enumerated on the previous slide. With Azure Functions, with the Azure SDK, you can do all that in just one step. It's all of the other concerns are handled for you.
Set up a container on blob storage, have it up, and then you're just editing code, and you're good to go. All right, deployment.
So the deployment story, here's an example of running Jenkins on Azure. So, this is kind of, these steps essentially were what was done for us earlier today when he made the git push. Yeah. Although it wasn't Jenkins, but it does serve to show you the flow. And the flow is the same regardless of what kind of CI/CD you're using. This diagram just shows you on the Jenkins side. This is enabled by, we have Jenkins plugins that are developed specifically for Azure, and the agent plugin and Azure delivery, artifact delivery plugins.
Yeah, those are built into pretty much every every CI/CD system has those right now. So.
Okay, so these are some deployment choices that we've commonly seen at customers. So lift and shift, of course, is when you're taking your existing workload and trying to move it into a cloud-like or cloud-enabled environment in some way without having to change or retool everything. Then the next level is Kubernetes and containers. Then you've got the hardcore greenfield cloud-native platforms, and going even further down the road, you can see serverless. And this is why I want you to take a look at the slides in the conference materials, because there's a wealth of information on the partners that we have established to bring and address getting to the cloud for all of these different perspectives. This is kind of a graphical representation of what was on that preceding table there. So we have PaaS, do-it-yourself PaaS, and infrastructure as a service as well. Okay, application insights. It's very important to have visibility into how your applications are running, and also that means telemetry. Oh, that was funny. Did it auto advance?
It did.
Oh boy.
It's telling us time's up.
Yeah. Okay. So we'll move on then.
Okay. Scalability. Look, we're out of time there, yelling at us. But basically, any of these. This is the cloud, basically. Any of these can scale with you, all right? And you can set it based on any metrics that you may want to, okay? That goes for a single function, a web app, containers, Kubernetes, our container service, our container instances, as well as our VMs. As far as Kubernetes and the open source, look, 30,000 contributors, 150,000 commits, top project in GitHub. Brendon Burns is the creator of it. He's now director of basically compute. He's director of engineering for compute in our container container engineering department. So resources and Q&A. We'll just
go next and next. There's Let's skip over to 50. There you go. Resources. You got it. Okay. So we'll leave you with this. And you get some links that you can take a look at. We have a lot of information on running Kubernetes service, and I mentioned the container registry there. So it's all up there.
Our container service, Red Hat OpenShift, and then just our Azure Red Hat OpenShift as well. So, and these slides will be available for now.
Yes, they're going to be making them available in the slide deck.
Okay, I think that's it.
All right. Thanks for your time. Enjoy the rest of your show.